Hi, welcome back to analysis. Last lesson, I've done this. I had talked about identifying positive ions, and I said we can use two methods. We can either react with sodium hydroxide a little and then add loads later and look at the observations, and we can identify 5 ions that way. They were iron 2 ions, iron 3 ions, copper 2 plus ions, ammonium ions and aluminium ions. And I went through that. Today, I'm hoping to get onto that step B, that we can identify things using flame tests. And I want to introduce you to flame tests today. If I take you through a few more slides, because there was a mistake yesterday, the previous video I mean, and that was this here. The AlOH3 aluminium hydroxide with excess sodium hydroxide made an ion that is AlOH4 minus, negatively charged ion. And I had the negative charge missing, which is quite important. So I did mention it yesterday, that was a mistake. I have put a red minus sign to signify the negative charge on the ion, and these ions are found dissolved inside the water, which is why the white precipitate of the aluminium hydroxide redissolves, because those are made. Now today, flame tests. I just want you to take you through how we do them. So we get a nichrome wire, and I'll show you in a minute. We make sure the nichrome wire is clean. Having got a clean nichrome wire, you dip the wire into the solid I'm going to use, into the solid version of whatever unknown you're trying to identify, and then you put it in the Bunsen burner flame and you look for the extra colour. The extra colour you get will identify the positive ion or the cation present that's in the ionic sample. I'm just going to pause this and take you over. Actually, may not even need to pause it. Maybe we can get down to looking at the so this is the apparition setup. I've got a beaker of tap water, which I'm going to use to clean the nichrome wires. I've got a nichrome wire here. I've got a fresh nichrome wire. I just want to show you, metal is nichrome, Bunsen burner on a blue flame. Nichrome wire, fresh nichrome wire goes in. Can you see all that colour? That colour is because of things, chemicals, that are on the nichrome wire. So the first thing to do is to get that clean. Dip it into the water and put it back in. And this time, there will be less of the colour. Dip it back in, less of the colour. And you keep doing this. You have to keep doing it until there's no colour. And when there's no when there's no colour, then you know that the nichrome wire is pretty clean. And sometimes you have to roast it for quite some time to get rid of all of this extra colour that arises. And the nichrome wire glows red hot. If your nichrome wire is long enough, then you can hold it with your fingers. If it's short, then you mount it in a cork and hold the cork. The other chemical that is better at cleaning nichrome wires is concentrated hydrochloric acid. But I don't want my GCSE classes using concentrated hydrochloric acid for safety reasons, and therefore I just use water, and there's little difference, to be honest, little difference, and therefore water is what I want you to use. And I think that wire now is clean and ready to use. I'm going to demonstrate doing flame tests with those chemicals I've got lined up here. Lithium ions, sodium ions, potassium ions, calcium ions, barium ions, and copper ions. Those are the ions that come up at GCSE. So lithium ions, I've got lithium chloride. Sodium chloride's got sodium ions. Potassium chloride's got potassium ions, etc. I'm going to try and get the video a bit closer and show you what I've got here. I have here put out the solids. I've put them into little watch glasses so that I can deal with them a bit better. So I've tried to rearrange the camera so it's close to the flame so you can see a bit more easily. Maybe we need to do that. I'm hoping you can see any colour we get in a minute. So nichrome wire, I have cleaned these before we started, so that should be pretty clean. Having cleaned it, then you dip it into water. Dip it in the water and then dip it. I've got solid versions of the chemicals here. Lithium chloride. See that red? That red is typical of lithium ions. Let's do that again. Water, dip it into the lithium chloride powder, and that gives you the flame colour red. Now we do have in chemistry spectrophotometers that will analyse that colour in much more detail. But there's only one chemical that gives that that red colour. There's only one chemical that gives that red colour, and that is lithium. So if we put that to one side, we get sodium. This is sodium chloride. I get a nichrome wire, dip it in, sodium chloride, and you see that? I've got the wire with solid sodium chloride stuck on it with moisture. I'm going to put it into the flame, and here now with sodium, the characteristic colour is a yellow-orange. See that? Yellow-orange. Okay. Having done sodium chloride, let's look at potassium ions. The chloride versions, the chloride ions in these chemicals, they do not give any colour. So any colour is down to the positive ions. Here I've got potassium. So any colour is due to potassium ions. Lilac. We're looking for lilac. Hope you can see that. Lilac. So learn these colours. Potassium ions give a lilac flame test. Now, calcium ions. Now these give a brick red colour. Now we've already had a red colour. If you remember, the colour we had earlier for lithium was red. This is a different red. No, didn't see very much red there. Let me just do that again. No, not getting the red that I want. So let me just get a lump. A lump. That is a lump of calcium chloride solid balanced on my nichrome wire. It's fallen off because it melted. I'm going to just try it once more and then I might show it to you in a different way. I don't think that I saw much red. Actually, that's quite interesting. If you bash your Bunsen burner, all the rubbish chemicals that are around the outside, they fall down the chimney and then they burn. And then you see all these wonderful colours. They're flame colours of various chemicals that have been spilt on the Bunsen burner. Now here I've got calcium. Hope you can see that. This is a squirty bottle. It squirts a solution of calcium ions, like calcium chloride solution, in there, and if I squirt it across the flame, I'm hoping you can see the colour you should see. Anyway, red. You have to learn that calcium ions give a red colour. It's called brick red because it's a dull red. So dull red, brick red, as opposed to lithium, which is red, which is much brighter, a bright red. Calcium, brick red, learn that. Now, barium ions. Barium ions. These should give, like barium chloride here, on my nichrome wire, should give an apple green. There, apple green. I saw the apple green. Let's do that again. Apple green. So that one does give apple green. I did see that. Normally the calcium works well. I don't know why it didn't work so well this time. Anyway, look, the barium, apple green. Look, initially when I put it in, there is apple green. There, apple green. Apple green. And finally, copper sulfate. Finally, copper sulfate giving a blue-green, a bluey green. It's a different kind of green, bluey green. Watch it again. bluey green. So I've come back to my PowerPoint. Let's get back up to where we were up to. Here. So flame tests. I've just demonstrated the flame tests. And I hope you learned that in the flame tests, that is how we do them. So we carry them out like that. And these are the ions that you can identify with those flame tests. 6 ions. Actually, I don't think barium ions are on the syllabus, but they're in that list. And then they're the colours. They're the colours that you've got to learn. So learn those colours. Now, red for lithium, sodium is yellow-orange, potassium is lilac, calcium is brick red, barium is apple green, and copper is blue-green. Learn those colours. Now, if you get those colours with an unknown chemical, then you know the positive ion is one of those. If you don't get those colours, then all you know is it's not one of those. So if we can identify positive ions, then the next stage is to get into negative ions. Now, negative ions in chemistry are called anions. And that's my next video. My next video will be how do we identify anions? And there are only 5 anions to identify. And we've got 3 methods. I'll go through it all next time. Otherwise, this video will end up being too long. See you then.